So good evening, everyone. This is JEE Advanced lecture number 2. In lecture number 1, we had seen, I think, all the four processes we had seen: isochoric, isobaric, isothermal, and adiabatic. We also saw that we can think of adiabatic process as the reverse of isothermal. We had seen their graph. We had seen that PV graph. We had seen an isotherm. We had compared the slopes of the different graphs. Yes or no? We remember that, right? We did not solve any questions on
thermodynamic processes.
yes, we did not solve any question on adiabatic, right?
Yes, sir.
And that is how we are going to start today's class with some questions on adiabatic process, and we will start with the simplest one. And the simplest question comes on your screen just now. Let me just reframe it. Let me just reframe it. Okay, here it comes on your screen. And remember, do not be worried about the values. The values that are going to come in JE would be very simple. 2 meter cube volume of a gas at pressure 4 into 10 raised to the power 5 Newton per meter square is compressed adiabatically so that its volume becomes 0.5. Find the new pressure. Compare this pressure with the result if the compression was isothermal. It's a pretty straightforward question, yes? Give me the answer fast. You may not give me the numerical value. You can just tell me this raised to the power this divided by this. That is good enough. I would understand that you got this.
P1
We
P1
just have to
V1
put the formula, right? And you have to compare the work done in both the cases. So this is just a recap of what we had done in the previous class. Were you able to do it, bacha?
P1 V1 minus P2 V2 by gamma 1 minus gamma.
Remember, do not do mistake in 1 minus gamma and gamma minus 1. This is the point where everyone does make a mistake. So please mind it.
Gamma
Okay.
minus 1. Yes.
P2 V2 minus P1 V1 upon gamma minus 1. Okay. Will you remember this?
Yes, sir.
Just remember this because you might make a mistake over here and I don't want you to commit the same mistake. Now, okay, you can do these questions. You can do this question. You can do this. You can do this. Okay, let me discuss these points. I think a question might come on these points. So let me discuss this. So I think you can do simpler questions where you have to find pressure from volume and temperature from pressure. You can do that, right? You just have to put the formula. Yes or no?
Yes, sir.
Let me not waste any time here. Just go through this sheet and here they have told us the slopes of the different graphs and work done in different processes. Do you understand this? Which one? The sharpest one is the adiabatic, then isothermal. Do we understand this?
Yes, sir.
So a question I have seen many times question come on these 3 points. Which one is adiabatic? In which case the work done is more? In which case the work done is less? And they might give you a multiple choice question on this. Multiple choice. Multiple choice is always a difficult one from compared to a single option. Do you understand this? Or
Yes,
shall
sir.
I? You understand this? Okay. Remember these points. And now we come to this question. Now I've seen in various years one of this question coming in your exam where they give you one graph. In this case they have given you a PT graph and they ask you the VT graph or the PT graph or the PV graph, the other two graphs. So if they give you PV graph, they'll ask you the PT graph and the VT graph. In this case they have given you the PT graph. You have to plot, I mean they will give you the plot, PV graph and VT graph for the corresponding. So I would ask you to draw the PV graph and VT graph on your own. I can't show you the options because it's not an objective question here. So draw the PV graph and VT graph and I'll show you the answers. Okay. Can you do that?
Yes, sir.
I'll give you a minute to do that.
Yes, sir. PV, VT.
PV and VT graph, and this is how the PV and VT graph looks. Where
Yes,
your
sir.
graphs correct?
Yes, sir.
Do I need to explain them?
No, sir. I have understood.
Okay, that is great. Everyone, I mean, how many of you do in the class, beta? Do we all understand this? Everyone?
Yes, sir.
Great. Then I shall move forward. And sometimes and many times I've seen question on this concept of free expansion. Have you heard about this concept of free expansion?
No, sir.
So just go through this. What I'll do is probably I'll share this sheet with you. I'll mail it up after the class today, so you'll get this sheet so you can go through this. Now, what happens in this free expansion, and many times questions have come in JEE Advanced. Um, we have a piston, we have two cylinders, two chambers, and we have a piston in between, and one of the chambers is evacuated. Have you seen a question like this? On this side, as you can see, there is nothing. There is no gas. There is no air. It's completely vacuum. Now, once you open up the valve, or and the gas is coming inside, they ask you what is the work done by the gas, what is the change in internal energy, and different questions can be set. Remember, this type of expansion where there is nothing on the other side, remember, now whenever, and remember this point, whenever you have found out the work done by a gas, you have written it as P into delta V or P dV ka integral. Yes or no?
Yes.
What was this P?
Pressure, external pressure.
Yes, this P is not the pressure of the gas. This is the external pressure. And we assume that the gas is in equilibrium at all points. So external pressure must be equal to the inside pressure. Here, the external pressure is 0, and therefore the work done in free expansion would always be would always be 0. Do we understand this?
Yes, sir.
And this is what you should remember.
For ideal.
In a free expansion, there is no work done, there is no change in internal energy, and there is no heat given because no heat comes inside. If there is no heat coming inside, that means all the three quantities would be 0. Do we understand this? That was for a real gas. Okay.
Yes, sir.
That was for an ideal gas. But what happens in case of a real gas? And they might ask you this as a multiple choice question. External forces ka work done is 0, but when you talk about real gases, we also talk about the interaction between the molecules of the gas particle. Do we understand this? That is the internal work. That work is not 0, and in therefore,
Internal energy is equal to negative of work done.
yes. So when internal energy will decrease, the temperature of the real gas will decrease, but the temperature of an ideal gas should remain constant. Remember this. Straight away a question can come on this. If what happens if this is a real gas, then they'll give you 4 options: 2 for real gas, 2 for ideal gas, and they will ask you which option is correct. We understand this? Please note it down.
Yes, sir.
Okay, you noted down. Then this is a small recap of CPCV, because we are going to deal with CPCV now. CV is R upon gamma minus 1. CP is gamma R upon gamma minus 1. And gamma is 1 plus 2 by F, where F is the degrees of freedom. Do we remember this?
Yes, sir.
Okay. Now, if we go on to the next type of process, and the next type of process is known as polytropic process. Have you heard about polytropic process?
PV power X.
PV to the power n or PV to the power x is constant. Now, if at all you come across a polytropic process, you can write it in the form of PV to the power x or PV to the power n is constant. For that pressure, for that process, you can write the molar heat capacity as C upon gamma minus 1 plus C upon 1 plus R upon 1 minus n. Have you seen this formula before?
Yes, sir.
Now remember this. If I multiply this by delta T, this term, I will get the work done in this process. You understand this?
Yes, sir.
If I multiply this term by delta T, I will get this is your CV. You understand this? If I multiply the first term by delta T, I will get the change in internal energy. If I multiply the second term by delta T, I will get the work done in this process. Remember, this formula is not valid when X is equal to 1 because then it becomes an isothermal process. Do we understand this?
Yes, sir.
Multiply the first term is NCV delta T. The second term will give you, if you multiply it by delta T, that second term will give you the work done in this process. Here they have not multiplied it by N because they have assumed that the number of moles is 1, so you have to multiply it by N. Okay, instead of R into delta T or NR into delta T, you can always write P2V2 minus P1V1. Do we understand this?
Yes, sir.
Okay, if you remember this, that means you are ready to solve any question that comes for a polytropic process. Okay, so let me see. Okay, there's one more thing that probably you would have seen. Efficiency of a cycle. Have you? Because most of the questions that come, they are on efficiency. You know the efficiency of a cycle.
Yes, sir.
Okay, so let us not waste time on this, and let us straight away jump into a question where everything that we have heard or learned so far is going to come, and the question looks like this. N moles of a diatomic gas has undergone a cyclic process ABC. Temperature at A is T naught, and then you are supposed to find out everything that is possible. I'll give you 2 minutes to solve this one, and I hope that you can do all the parts together. Remember, there is no numerical value, so the answer should come quickly. So, what was the first question we were supposed to find out? The volume at point C, and the answer is 2V naught. And you got the answer as V naught by 2. Is
Yes,
that correct?
sir.
What's the problem? See, that is the problem.
Okay, sir.
What? Okay, sir. Do you understand how it is 2V naught?
Yes, sir.
And how did you get V naught by 2? You only saw that pressure is 2P naught, and then you somehow got that it was an B2C was an isobaric process, right?
Yes, sir.
A to B was an isochoric process, right?
Yes.
Yes. And then you can apply, they have put similar triangles. Even if you don't apply similar triangles, you can get it by logic that. Do you understand how it is got? Shall I solve it for you? Let me show you the diagram once again. And now since you know the solution, you might be able to understand it better. So here was the problem. See, similar triangle. Do you see similar triangle here?
Yes, sir.
Yes, now you see it. That is why you need to solve the problem. This is a similar triangle, bacha. This one. Okay. Both the triangles are similar. So from there, in this, if I just color it by red, this red triangle, perpendicular divided by hypotenuse, and the blue triangle, perpendicular divided by hypotenuse, should be same. Do we understand this?
Yes, sir.
Now, you gave me the maximum temperature also wrong. You told me that it was 2 T naught. It is not 2 T naught, it is 4 T naught. Do you understand this now?
Yes, yes.
Pressure has become twice and volume also has become twice. So temperature has to become 4 times. Do you understand this? That
Yes,
means the
sir.
rest of the answers would be wrong as well. Well, let us not waste any time into checking those, and let us just see Once you get these two correct, how do you get the work done? The work done is very simple. Work done. This is a cyclic process. So work done is area under the graph. Yes or no?
Yes, sir.
Between the graph, and that is half P naught V naught.
Yes.
Now you have to understand in which process the heat is rejected and in which process the heat is given out. So you have to look at both the processes and see where you will have heat rejected, and heat is rejected in the process from C to A. Do we understand this?
Yes, sir. Negative is the
So you can calculate the work done from C to A. You can also calculate the change in internal energy because you know the temperature at C and you know the temperature at A. Yes or no?
Yes, sir.
That will give you the heat rejected in this process. Once you have the heat rejected, and it will always come as negative, then you can calculate the efficiency of the cycle. Efficiency of the cycle is work done divided by heat input.
Yes.
You know work done, you know heat rejected, you can find out the heat input. Yes or no?
Yes, sir.
Efficiency is going to come like this. Okay, do you understand what mistakes you had done?
Yes, sir.
Okay, now let us quickly go through this small portion of Carnot cycle. Do you know this Carnot cycle as an ideal cycle with maximum
sir.
efficiency, two adiabatic and two isothermal? Yes or no?
Yes, sir.
Many a time question come on this. So you just go through this formula. You must know which process is adiabatic and which process is isothermal. Yes or no?
Yes, sir.
And you must know the efficiency of Carnot cycle. Do you know this?
Yes,
1
sir.
minus Q2 by Q1 by 100, 1 minus T2 by T1 by 100. Carnot theorem. Do you know Carnot theorem?
Yes, sir.
Do you know heat engine? Working
Yes.
on Carnot theorem? Yes or no?
Yes, sir.
This one?
Yes, sir.
Okay. Then the reverse of this is known as refrigerator. Do you know this? The reverse of
Refrigerator.
this,
Refrigerator.
yeah, the reverse of this is known as refrigerator. You know this?
Beta.
Okay, beta. So instead of telling you the theory,
Q1 by
I
Q1 by Q1 minus Q2.
instead of asking you Q1, Q2, I'll just give you a question and find out whether you know it or not, right? That is better. So this is the question. Multiple choice, single option correct. This is how question come and this is how you'll apply what you've understood. I'll give you a minute to think about it.
F.
As you can see, the answer is pretty simple. You just have to apply
2
the
by
formula.
3.
Which one?
Efficient. 2 by first one 2 by 3 into for 16 degree for 1500 degrees and 500 degrees Celsius is 2 by 3.
Okay.
I,
Then you just put it in the formula. First,
yes,
you
sir.
increase 1 by 100. So it becomes 1600.
Yes, sir.
So it becomes 1873 Kelvin. Yes or no?
Yes. Yes, sir.
Then you find out this. It is coming as 0.59.
Yes, sir.
Then you decrease the other one. When you decrease the other one, you find it has become 1.62. So decreasing the sink temperature would affect it more. Yes or no?
Yes, sir.
Okay. Refrigerator again. I would again give you a question on refrigerator. Instead of giving you this one, I'll give you this one. This has, okay, this one is different. Let me give you this one. Okay. Here comes a question on refrigerator, and your time starts now. Why is the question not coming? Yes, the time starts now. A Carnot cycle, a Carnot engine works with the refrigerator between 250 Kelvin and 300 Kelvin. If it receives 750 calories of heat from the reservoir at lower temperature, calculate the amount of heat rejected at higher temperature. Simple one. Test your understanding of the concept. Remember, no one is going to ask efficiency straight away. What is efficiency? No one is going to ask you that. Just twist the question in a way where it looks a bit frightening. Yes, even now it is a straightforward question. May I have your answers, please? You must remember simple things. And you forgot the basic concept. And that is what landed you in trouble. Q1 by Q2 is T1 by T2. Simple thing. Yes or no? Yes or no?
Yes, sir.
That's it. That's your answer.
I had did like this. First, I had calculated efficiency. Then
Why go so far when you can do it here like this? The only thing you got to remember is Q1 by Q2 is T1 by T2. It's as simple as that. Remember, JEE, even it is main or advanced, some questions are simple. They just check your speed, how quickly you can do this. Bacha, theek hai? You understand this?
yes, sir.
Why I'm doing this question? Because I don't know. I feel that this time probably a question on heat engine or refrigerator is going to come. And this one, can you do it now? The temperature inside and outside of refrigerator are 260 and 315 Kelvin. Assuming that the refrigerator is reversible, calculate the heat delivered to surrounding for every joule of work done. Same thing asked in a different way. For 1 joule of work which is done on the refrigerator, how much heat is delivered to the surroundings? Refrigerator takes the heat from inside and puts it outside. Inside, puts it outside. For 1 joule of the work, how much? See, a simple question framed in a way, and we get confused. A minute you'll get for this one. You're done with the solution, yes or no? So basically, this is how you need to calculate it. The coefficient of performance beta is Q by W, which is nothing but T2 divided by T1 minus T2. Yes or no? Yes, work done is 1, and you have to calculate how much heat is given out, taken out. That's it. T2 upon T1 minus T2, and that is your answer. Did you get it, bacha? No? Okay, that means you are lagging out here. Don't worry. I'll give you one more chance to redeem yourself, and I hope if you can do this, that means you have understood the entire concept of refrigerator and heat engine. Here it comes. A refrigerator takes heat from water at 0 degrees Celsius. Remember now this calorimetry also comes, and this is how they mix two things. This is only thermodynamics. So they are mixing one part of thermodynamics with the other part of thermodynamics. A refrigerator takes heat from water at 0 degrees Celsius and transfers it to room at 27 degrees Celsius. Wow. If 100 kg of water is converted into ice, now you are making a refrigerator. Calculate the work done. It give you time. If you can do this, that means you have done all the questions which were above this. 2 minutes is what you'll get. So here we go. What you got to do it. Remember, how much amount of heat you have to take out. You have to
336. 336.
Yeah, good. That is correct. 3.36 into 10 to the power 7. That is correct. So basically you have to convert 100 kgs of water into ice. How much heat you have to take out? Q2, which is M into L. And then you have to calculate what is the coefficient of performance of this gentleman. T2 upon T1 minus T2. Water is at 0 degrees Celsius, 273 Kelvin.
Yes, sir.
That's it. You understood the concept behind this?
Yes, sir.
Great. Well, now here is a mix of questions, but instead of going into mix of questions, there's anything in thermodynamics that you need me to cover? Or what I'll do is, let us solve questions on first law of thermodynamics in this class. In the next
Yes, sir.
class, we will do a mixture of all the questions of thermodynamics. Okay.
Yes, sir.
So let us first wind up this thermodynamic processes. And here is the question, and I need a quick answer. Certain perfect gas is bound to obey PV raised to the power n is constant during an adiabatic process. Ooh. N would be gamma probably. The volume expansion coefficient at temperature T is. You might not have heard about this term, volume expansion coefficient. Have you heard about this term? Sometimes they ask you such terms which you might not know. Volume expansion coefficient. Well, let me not waste much time into that because I don't think you have heard this term. Have you heard this term? Yes? Well, if you heard this term, then congratulations, you know 70% of this question. Tell me what is the answer.
1 by 1 minus n into t.
That is absolutely correct, and that is how it is done. Delta V upon V divided by delta T, that is the volume expansion coefficient, and you just had to calculate it. The process was given in terms of P and V, converted in terms of V and T, and then calculate delta V by V or delta V by delta T, and we are done. Well done, nice job. I was not expecting that you would be knowing it, but it is great if you know it. Then comes this one. This would be probably easier one. And again, we are dealing with questions on kinetic theory and thermodynamics because they are related to each other. And this one, 5n and 5n moles of monatomic, diatomic, and non-linear polyatomic gas, which do not react chemically, are mixed with each other at room temperature. The equivalent degree of freedom for the mixture is. Remember, degrees of freedom for a monatomic gas is how much? 3.
3. Yes, sir.
For a diatomic gas?
3. 5. 5, yes.
For a non-linear
7.
polyatomic gas?
9. 7 కదా 7 7
6. Okay. 3 for translational and 3 for rotational. Okay. If it is a linear polyatomic, it is still 5. Do we understand this?
Yes, sir.
Okay, then what is the answer for this one? If you know these degrees of freedom, then it should be a cakewalk. What is the answer? You have got 4 options here. Oh, so much time? Not good. And the answer is A, B, C, D. Which one? Here is the answer, and this is how you do it.
Yes, sir.
F1 and 1.
Yes, sir.
Basically, change in internal energy should be 0, right?
Yes, sir.
F1 N1 delta T, F2 N2 delta F by 2, whatever the formula is, that should be equal to F equivalent into N1 plus N2 plus N3. Okay? Got this?
Yes, sir.
Remember, the temperature has not changed. Okay. Okay. Let us see if you can do this one. I'll have to decrease the size of the diagram because it is a bit big. Wow. Let us see if you can do this. Remember, this is how questions are framed in a JEE. Shows the adiabatic curve on a log-log scale. Log-log scale. The gas must be. Log-log scale. This is how questions are framed, beta. Do not get trapped. It's log-log scale. T and V. Log T, log V. I'm waiting for the answers.
Option C.
Option C.
Yes, sir.
How did you get option C? Guess? Guess?
So monoatomic and diatomic.
How did you get it? Guess?
I
Remember, this is how you do
Gamma.
it. You somehow
sir.
find out the value of gamma for this, right? You can find it out. This
Yes,
is
sir.
this is how a adiabatic process looks like. The gamma for this mixture, the gamma for this thing is coming as 3/2. For monatomic gas, it is 5/3. For diatomic gas, it is 7/5. And then you understand it's highest for a monatomic gas. Then it is diatomic. Then it is polyatomic. And this gentleman lies between mono and dia, and therefore this is a mixture. Do you understand this?
Yes, sir.
That is the concept behind this. If you got this, well, congratulations, because you have done great. Now here comes my favorite, polytropic process. And the first question in this process, and this is how the question looks like. And the problem is, if I have to make it come in one screen, I would have to decrease the font and rearrange it. And here it comes. And I'm expecting an answer fast. Figure demonstrates a polytropic process, PVH to power n. Remember, n is a constant for an ideal gas. The work done by the gas in the process A to B. Option A, option B, option C, option D is my favorite. Insufficient information, I can't solve it. That's my favorite. But that doesn't mean that that would be the answer, because favoritism only works in politics. It does not work in JEE. I tell you, the director of my college, he tried his level best to get his son into the college, but he could not get it. He could not get him because he could not bug JEE. Okay? So favoritism doesn't work. Yes, you have an answer. This is how questions are framed in a JEE. Simple things. Yes. The answer is definitely not D. D is my favorite, but it's not D.
Option B. 14/3 P naught V naught.
How did you get B out of all these four options? Guesswork?
Yes, sir. P1. 16 P naught V naught minus 2 P naught 2 V naught.
Yes. You first of all find out the value of n. Take any of this and put it in the form of P raised to the power n is constant. From there, you will get the value of n as 4. Then you put P2, P1 V1 minus P2 V2 upon n minus 1. Remember this formula? Yes, beta? Any doubts? Is it okay, beta? Any doubts?
Yes, sir.
Clear?
Clear.
Then comes this one. And here they made the question simple. And this is the language that they use in a JEE. Take ln9 as 2, take R as this. They will give you values if those values come. Suppose 0.5 mole of an ideal gas undergoes an isothermal expansion as energy to is heated to it as heat Q. You can see Q here. They have drawn a graph. Graph shows the final volume QF versus Q. The temperature of the gas is. See, a simple question put differently. And that what causes a bit of confusion. I'll give you a minute to think about it and I'll be back.
But confuse हो रहा.
That is how questions are asked beta in a JEE. Look at the graph, everything is given. It's an isothermal process. Amount of heat given is work done. You can calculate the amount of heat from initial point to the final point. 1500 joules. Work done is nR T ln V final by V initial. From there you calculate T. That's it. As simple as that. ln9 is given as 2. So ln of 3 becomes 1. And you have your answers. Yes or no? No, yes.
Yes, sir.
See? Simple question. Put in a different way. It looks a bit confusing. Don't get trapped. This is how questions are framed. And now let us see if you can tell me this one. Remember, whenever a question comes in a JEE, they will not give you the most expected graph. They will give you the least expected one. TP graph, not PT, it is TP. They change the axis sometimes. A given TP graph for 3 processes. If it was a PV graph, this question would have been a cakewalk, but then they make it a TP graph. Initial and final pressures. Oh, initial and final pressures are same for all the processes. The correct order is
Sir, B.
which one? B. What is the logic behind it?
Area under the curve.
Area under the curve? TP graph?
Yeah.
It's not a PV graph, bacha. It's a TP graph.
Okay.
So, but I must congratulate you that your guess, even though your concept was absolutely wrong, your guess was actually correct. Your guess was actually correct. And the reason behind this is this. Between T and P, the graph is drawn, and remember this concept. This is graph number 1, graph number 2, and graph number 3. So basically, you can write T as a function of P. Yes or no? P raised to the power n, right?
Yes, sir.
Here, the value of n is greater than 1. That means pressure here is more.
Work done is less than 0.
Right?
Yes, sir.
So work done here is greater than 0 in this.
Negative work 0. Yes, sir.
This is an isochoric process, yes?
Yes, sir.
Yeah, that is how you get the hint. This gentleman is an isochoric process.
Yes,
and then you have a process which is above this, then we have process behind this, below this, but TP graph is given. So that was the logic behind it. Do we understand this, bacha?
Yes, sir.
Okay. Remember these things because sometimes a simple question is put in a different way and we get confused. This one, remember, one of these questions will come. One of these graph is going to come. Figure shows the variation of internal energy U with density rho. See, they'll give you the least expected graphs and then you get puzzled. For 1 mole of an ideal monatomic gas, is given for this thermodynamic cycle A, B, C, A. Here process AB is part of a rectangular hyperbola. XY is equal to constant. Do you know rectangular hyperbola? Which of the option is correct? I'll give you time to do this, a minute. And let's hope that you don't guess and get the correct answer. You have the correct logic and then you get the correct answer. 1 minute. This time I guess you have guessed it. And this time I must congratulate you in telling you that your guess is absolutely wrong. And the answer is not D. So from the next time onwards, you should not guess and you should understand the problem. We had to contend with B, rectangular hyperbola. U into rho is constant. Yes or no?
Yes, sir.
U, internal energy, is NCV
Okay.
delta T. Yes or no?
I have
Into
taken
rho.
PM equal to DRT. I have taken PM equal to DRT. That's why I got.
So P is equal to rho RT by M. And rho RT is constant. Molecular mass has to remain constant. This is, my dear gentlemen, isobaric process.
Internal energy.
Yes or no, bacha?
Yes, sir.
And then you see in this process, volume is getting decreased. And the cycle, then you get the cycle of a PV graph that will give you work done. Clockwise is positive, anti-clockwise is negative. So the question is done. This is how questions are framed, beta. Do you understand this?
Yes, sir.
Yes, sir. Then you can always redeem yourself with the next question and let us see how much you can do with the next one that comes. And this is the next one. And I hope and I think that you have not seen questions of this type. Let's see how you can do with this one. 1 mole of an ideal gas undergoes a process where molar heat capacity is 4R. These are type of question given in Erodo. And in which work done by a gas for a small change in temperature is given by the relation dW is 2R dt. What is the ratio of Cp by Cv? So gamma is what you need to find out. You have 2 minutes to think about this. I'll give you time. If you can do this, well done. 3 by 2, and this time I must congratulate you that your answer is correct. And I guess your process is correct as well. dq is du plus dw. We all know this, yes or no? nc dt is ncv dt plus 2nr. And then getting cancelled. So you get C is equal to CV plus 2R. This is given as 4R. This straight away gives me the value of CV. Once I get the value of CV, rest is history. This is the exact way you have done this, yes or no?
Yes, sir.
Good. That means you have understood what we are doing in the class. Okay, heat conduction. Do you want to do heat conduction as well?
Yes, sir.
We will do all the other problems in the next class. Okay, a mixture of all these problems we'll do in the next class. Today I'll just concentrate on the processes. Okay,
Okay, sir.
in the next class we'll do the remaining question which has calorimetry and all those heat transfer and this and that. This one, a gas undergoes an adiabatic process in which the pressure becomes 8 by 3 root 3 times and the volume becomes 3/4 of the initial volume. If the initial absolute temperature was T, what is the final temperature? It's a straightforward question. You should always be ready for these straightforward questions because anytime this question can come, you should be ready to give the answer in a flash. In a flash means quickly. So they have given pressure, how much pressure has changed, how much volume has changed. Asking you how much the temperature has changed. Which one is correct here? Well, confused?
Oh, sir, wait.
Okay. So the correct option is B. As I said, the only problem with this question was gamma was not given. So if you encounter a question like this, now you have done this, you might have taken 2 or 3 minutes. But now when the next time this question comes, you should be able to solve this. Yes or no?
Yes, sir.
That is the advantage of doing what you call as homework. This is what I call as doing your homework correctly, because if you do these things at home, you would not be getting caught in the exam. And now I come to my favorite questions, which are multiple option correct. And this is the first one of this category. 10 moles of an ideal triatomic linear gas undergoes a process in which the temperature changes with volume according to this equation where K1 is a constant. Which is the correct alternative? Slash S. Yes, beta. Now this tests your understanding of the topic. Do I have anything that looks like an answer? Yes? No? Shall we discuss the answers then?
Just wait, sir, just 1 minute.
Okay. Options A and option C. What about option B? Option B is also correct. Cp minus Cv always remains R at any temperature. But at higher temperatures, the degrees of freedom change. Do we know this?
Yes, sir.
Even though the degree of temperature change, degrees of freedom change, the relation between Cp and Cv remains constant. Will you remember this?
Yes, sir.
So the correct options are
A, B,
A,
C.
B, and C. Okay? We all got this?
Yes, sir.
This one, again, a simple question, but the options might confuse you. An ideal gas expands in such a way that PV square is constant throughout the process. Select the correct alternative. So this is a single option correct. The expansion is not possible without heating. Expansion is not possible without cooling. Internal energy remains constant in its expansion. Internal energy increases in its expansion. This question could come as a multiple choice one. You have to look at all the four options. Here it might be a single option correct. You can get it as multiple option correct as well. The gas is expanding.
Got one.
Which one?
Option D is correct, sir. The internal energy increases in the expansion. Option D I got. No. It's a polytropic process.
It's a polytropic process. Option D is correct. Is that so?
Yes, sir.
Okay. Everyone is getting the same answer, bacha? Then I must again congratulate you. But this time your answer is not correct. PV square is constant. PV is an RT. So PV square is V into T. It's constant. Volume is inversely proportional to temperature. Volume expands, temperature decreases. It's not possible to expand it without cooling. Do we understand this?
Yes, sir.
And if it is expanding, it is cooling. So internal energy is decreasing here, bacha. So there could have been an option where they give you the internal energy is decreasing, and it becomes a multiple choice correct.
Yes, sir.
We get this?
Yes, sir.
Okay, then comes my favorite one, multiple choice.
Okay.
And remember, these are the questions that are going to puzzle you. Okay. But I'm sure once you are done with all this, I'm going to cover each and every combination of the question that is possible. So whatever question comes will be a part of this. Which of the following process must violate the first law of thermodynamics? Delta E means change in internal energy. I hope you understand this. Again, it's a question just based on the first law of thermodynamics statement. That's it. How good you understand this statement is what I'm going to understand now. How good is your understanding of the statement of the first law of thermodynamics? And your time starts now. I'll give you a minute. I have the answer, and the answer that you have given is option A and option C.
Yes, sir.
And again, I must congratulate you. This time you are correct. Option A and option C. And I hope you understand the logic behind it.
Yes,
Do you
sir.
understand the logic behind it?
Yes, sir.
You have applied the same logic. So let me not waste any time in this. And move on to the next one. Checking your understanding of the topic. Here it comes. My favorite, multiple choice. Just the understanding of how much we know about this. In a process on a closed system of an ideal gas, the initial pressure and the volume is equal to the final pressure and volume. Wow. See, simple question put in a different way and you get puzzled. Uh-oh. One of the option is quite simple, but let us look at the other ones. Which?
0, sir.
Which one? A, B, C, D.
B is correct.
B is correct, definitely. Anything else? B is definitely correct. No problems about B, right?
Sir.
If B is correct, then D is also correct. If no work is done on the gas, no work is done by the gas also, na?
What done? 0, sir.
Work done is 0, sir.
Yes,
And I must tell you, sir, that is the wrong option, sir. Because the correct option is this one. The internal energy of the gas must be equal to the final internal energy. P and V are same, beta. It's a closed system. No gas is coming in. The temperature has to remain same. It must be a process where it's a cyclic process. The cyclic process is happening. Pressure and volume are same. So internal energy is same, and the change in temperature. There is no change in temperature. It's a simple question of a cyclic process put in a way where you get confused, and you got confused, right? See, don't get confused by simple questions put in different way. Do we understand this, bacha? Again, one of my favorites. Graphs, thermodynamic process, and multiple choice. They make a very good combination. The graph shows, remember, it's not a PV graph, it's a VP graph.
graph.
Remember, they will change
Yes.
something. They will change something. The graph shows VP graph for 3 processes. Choose the correct statement. Number 1, number 2, number 3, number 4. Now give you a minute to think about it. Remember, it's the VP graph, not a PV one. Let's see which of them is correct, and the correct options are A and C. A is obviously correct. Yes or no? Now look at B. B says must increase, and there is a problem with must. If it was may, it was correct. Do we understand this? Do we understand this? If it was may, then this option was correct. This is must, so this option is wrong. Option number D is wrong, right? Option number C, heat must be supplied in the process. It's an
Yes, sir.
isobaric process.
Positive.
Pressure is increasing, right?
Yes, sir.
No. Pressure is constant, volume is increasing, temperature must increase, right?
Yes, sir.
Heat must be supplied. Both are positive. Yes or no? So this is
Yes.
how, please remember, beta, sometimes they will just change the axis of the graph and you would fall flat. And this is how they frame questions. They will give you the most unexpected graph. And just by changing a simple thing in the graph might look quite different. See this one. Every time we see P, relation between P and V, P and T, V and T, but what happens if P and rho come? Doesn't matter, it's still the same question. Do we understand this? The question is still same. The only thing is, if something different comes, you just relate it with the things that you know and you are done. During an experiment, ideal gas is found to obey the condition P square by rho is constant. Rho is the density of the gas. The pressure, the gas is initially at temperature T, pressure P, density rho. The gas expands such that the density changes to rho by 2. Which are the options which are correct? I give you a minute to deal with this. Okay, option B is absolutely correct. No doubts about it. Option A is absolutely wrong. No doubts about it. Yes or no?
Yes, sir.
Okay, what about C and D? Graph between P and T, beta. Graph between P and T.
Confusing.
Confusing? No, it's not confusing. It's not confusing. You know this, yeah? P is equal to rho RT by M. 2 or 3 times we have done question on this. Rho RT by M. R is constant, M is constant. So P is proportional to rho into T. But P square by rho is constant. So you can find the relation between P and T. Yes or no?
Yes, sir.
It will come as a hyperbola. Yes or no, bacha?
Sir, how pressure changes, sir? Temperature changes, na, sir?
Chill, chill, chill. P square by rho is a constant. Yes or no, mere bacche?
Yes, sir.
P is proportional to rho into T.
Rho into T.
Yes or no? So from here I can put rho as P square by T. P square by
P per T.
P square by constant. Yes or no?
Yes, sir.
This goes away. Constant comes here. So P into T is a constant. Yes or no? It's a rectangular hyperbola, beta.
Okay, sir.
So basically, this entire thing resides on three things. PV is equal to nRT. Do we remember this equation?
Yes, sir.
P is equal to rho RT by M. Do
Rho
we
RT
remember
by
this?
M.
And this one. All the
Yes,
questions
sir.
are based on
Clear, sir.
these three equations, beta. Don't get confused. You know everything. I can see that. You know everything. You just get confused in simple things. Just don't get confused with those simple things. Do we understand this?
Yes, sir. Clear, sir.
Okay. So what we'll do in the next class, I think I'm already almost done with the questions of this type. 2 or 3 questions are left. The next question that I wanted to show you, let me just show you. A similar question I did with the last year crash course. A similar question, and would you believe the same question came in the JEE exam? The only thing that was different was my volume on the other side. The right hand side was V0 by 2. And I think V0 by 4 came in the JEE. So it was a similar question like this, not exactly same, on similar ground. So what we'll do is we'll try to solve more questions on this. Now in the next class we'll take all the combined questions. So we'll have questions where they will be cylinder, piston, and all those things. And we'll also try to take some questions on thermodynamic, on calorimetry and heat transfer. So probably in 2 classes we'll be able to complete your thermodynamics as such. Okay. We'll try to cover all the questions that are possible. So we'll see. I'll see you in the next class tomorrow. Okay. Do you have any doubts? You can ask me now. Else, the class seems to be over from my end. Anything else you want to ask me? Please ask.
No, sir.